I've vamped enough. All right, Charity Majors is a co-founder and engineer at honeycomb.io, a startup that blends the speed of time series with the raw power of rich events to give you interactive, iterative debugging of complex systems.
Shit, yeah, sounds great.
She's talking about Scuba, which you heard about in the last talk, diving into data at Facebook. Give it up.
Yeah. Hi. This is actually my first time at any Papers We Love. Inez and Katie have been trying to get me to come for like years. And it's been on my list. I haven't done it largely because I am not a computer scientist. And it just seems so very computer science-y. When I think about computer scientists, I think about people who care about things like, I don't know, numbers and like fancy squiggles and shit. I'm a classical piano performance major. I studied Latin and Greek, electrical engineering, philosophy, and dropped out after 4 or 5 years of school because I loved working on computers more than my majors. Emphasis there is working on computers, not playing with computers, which is what I feel you guys do. Okay, I'm not slamming computer science. I value the work that you do, but I feel like you take computer science, you add a little bit of reality, and then you have software engineering. You add a little bit more reality, and then you get infrastructure, which is where I live. So this is what I do with my life. But Zishan asked me to come, and I was like, well, if I say I'll give a talk, then I probably can't flake. So I came. That's super cool. I really enjoyed your talk, Quinn. That was so awesome. I am going to talk about the Scuba paper written by Facebook, literally because he said, will you talk about a paper? And I thought, and it was the only paper that I could think of other than the RAF paper. And I'm like, I'm not going to go talk about the RAF paper to a room of computer scientists. they'll like find tomatoes to throw at me. I like the RAF paper, but come on, I know my audience. But I do actually, I like this paper, and it's a very, you'll see why I like this paper. I won't, no spoilers. But I actually like this paper so much that I started a company because of it. So there's backstory. Here are the things that Facebook needed. I actually think this is really hilarious. Have you guys ever noticed that there are no good tools for inspecting your database traffic out there? And I feel like it's because, there's Vivid Cortex recently. There's a lot of homegrown crap. But like the stuff that we use for monitoring our systems for the last few years, I feel like we took this giant detour into metrics land. Now, when you start talking to like engineers who are not in computers about event-driven debugging, or they just kind of look at you like, what? I'm like, well, metrics. And they're like, what the fuck is a metric? They're like, data. And I feel like the reason that we took this detour, like it makes sense in retrospect. Like we had these big websites. We needed to understand what they were doing. And hardware was so expensive. Compute was expensive, disks were expensive and slow, and RAM was just like ungodly expensive. And so we're like, how can we just like throw away as much detail as possible and still get something? And thus the metric was born, right? And over time it's been like, well, how the fuck do we find our metrics? Well, I don't fucking know, let's add some tags. Like the right application just starts blowing up. And it's just like, okay, this is the story of our lives, and this is how we know how to tell what's going on with our computers, and it's kind of busted in a lot of ways. I don't know if you noticed this, but hard drives are really cheap now. They have SSDs, which is super cool. And I feel like it's time for us to redevelop these muscles that we used to have, because debugging with events, debugging with sentences of data, phrases of data, is so much more intuitive. It's the way that our brains think, Events tell a story in a way that we have to impose a weird narrative on metrics and whatever god-awful thing that we've done with them. Anyway, that was a detour. But Scuba was a detour too. Scuba was what happened when Facebook had this, cutting-edge, world-class, metric system, and went, we have no idea what's going on with our databases. Like zero idea, sub-zero idea. Our metrics and our dashboards are actively misleading us because they're all aggregates. And turns out, if you want to understand what's going on with a database, you need a very wide row. You need an event. You need to have the query, the raw query, the normalized query family, the host that it came from, the comments that were attached to it, all of this information about it, and you need it all to happen at the same time. So they hacked something up. I don't know if you've ever seen Facebook from the air. It has this giant hack in red letters. First day after we were acquired, my counterpart in the API side was like, yep. Yeah. Well, but hackathon upon hackathon. And it grew into it evolved into a thing that, I'll describe some of the many workloads that it performs. Like, okay, so you're running like Facebook all over the world, right? And a few users in Indonesia are complaining that photos are loading slowly. Are they all family members who are just like getting around the Thanksgiving table and complaining, and that's why they all filed reports? Is it a router somewhere in, is it a language pack on this version of Android that some of them are using? Is it a problem with, some feature that they've turned on for some local holiday? Is it a problem with a local group? It could be any of these things. And if you start out by assuming you know what the answer is, well, there's fucking millions of possible answers. You're not going to find it. You have to start out with an open mind, and you have to start out with not a dashboard of possible artifacts of past failures. You have to start out with questions that you can iterate on. Group by source and destination data centers to bubble up the high latency saturated links. Find the top, order of magnitude of sick machines based on thread queues, or any one of the hundreds of TCP stats in /proc. Show me a heat map of servers by their CPU consumption, or by racks, by their packet throughput. When you start thinking about systems this way, it makes it, like, I believe in the future we're all distributed systems experts because we have to be. Like if the computer science of distributed systems is really just computer science, it's science about complexity and far-flungness. And in the future, that's all of us. I feel like the tools that we developed in the LAMP stack era are not just showing their age, but they are like knocking on death's door. Like the past generation of tools were so good at answering the known questions. You've got a question, they'll fucking answer it. Boom, they're really fast. But like with problems like these, well, if I knew what the question was, I could answer it very quickly. I don't know what the question is. Can you tell me what the question is? No. Anyway, I should get back to the paper, huh? So when we got acquired, when Parse got acquired by Facebook, I think we were running 60,000 mobile apps is what we were managing, backend as a service, mobile backend as a service. And we had built a system using like best of in class of like open source, metrics and dashboards and all this shit, and it was effectively undebuggable. And we get acquired by Facebook, and they just start telling us, oh, your problems are trivial, they're simple, use this, and it caused more problems than it solved. The one thing that was not true of, actually we got to Puma later, that was interesting in a different way, but the one thing that like made up for all the other things was Scuba. We started getting our data into there, and we started exploring it. And suddenly these questions, people were coming to me every day like, Parse is down. I'm like, no, it's not. Like, look at my beautiful fucking wall full of dashboards that tell you how very not down Parse is. Like, they don't care, right? I'm just losing credibility when I argue with these dudes. And I get it, right? It's their mobile app. Maybe it's their entire revenue, their business, whatever, and I'd be pissed too. But all I had was aggregates. All I had was metrics. And there is just no way using something like that to do something very high cardinality, like break down first by this one application ID, and then by every combination of everything else, right? Endpoint, calculate latency percentiles on the fly, query, when did that query get deployed, problems like, before that, I could solve it, but it was like I would go on an expedition. I'd be like, fuck, I'm hearing a lot about this thing. I'm gonna don my hat and just like take hours or a day or a week and figure out, is this a systemic problem that only a couple of people are running into? Is it this one person? Is it something they did? Is it something we did? Whatever. We got our shit into Scuba, and suddenly it was like, click, 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 boom. That is addictive. That dopamine hit, just like, oh, fuck, I found it. So I cared. And went through kind of a mini version of the story that the rest of Facebook had gone through earlier. All right, there's a bunch of stuff in that white paper. I'll let you read it about. Oh, and it's all old, too. They're like, today, Scuba runs on hundreds of servers each with 144 gigs of RAM, a shared nothing cluster. So originally, you know how nowadays, I got in a Twitter war just last night. Somebody's like, the only problem with this is like the cost of storage. We know how, these are all solved problems. I love it when people tell me that on the internet. Solved problems, known science. It's just the cost of storage. I'm like, well, okay. Facebook did this in 2011, and yes, back then, they had to run it with servers that had 144 gigs of RAM. Yeah, that was expensive. But it's been 6 years. We now use SSDs, and they're quite cheap. The thing is, sampling. I don't know if you're familiar with this computer science concept. The sample. It's pretty cool. Dynamic sampling, a thing that Facebook does that we also do that was really cool is you just make the sample rate an attribute for every event, and then you just like do more math, calculate it back up. Cool, right? So like for your 200s, Instagram would keep 0.1%, Parse kept like 20%, but for your 500s, well, you keep all of them. That's really nice. And then you just rely on like server-side limits to cut the top off the mountain when your site goes down. This is what Facebook does. Every team has many Scuba tables. This brings me to the reason number one that I love this paper, actually. This was written by not computer scientists. This was written by infrastructure people who kind of, after the fact, wanted to look really cool, so they wrote a white paper. It's very obvious. But embedded in this white paper are lots of awesome cool clues about how to do event-driven debugging or distributed systems debugging at scale. And honestly, like the stuff that Facebook was doing in 2011 is pretty much exactly applicable to like the center of the market nowadays, right? Because there's this trend, right, where like the stuff that Google was doing, 10 years ago, Facebook was doing like 4 years ago, and all of us are doing now. Maybe not in sheer numbers, but like the categories and types of problems and the tools that are available to us. Oh, and this is called, I just learned this, a rain boom explosion in the My Little Pony universe. I just thought you might need to know that. These are a few of the things that they do with Scuba. A/B testing. This is not just for engineers, right? This is for normal people with their normal people brains. Is anybody using this feature that we developed? Cool. Bug reports that are coming in, aggregating them. And this is where I got religion about consumer quality developer tools. It turns out developers are people too, subject to some of the same cognitive biases, and more importantly, we should not spend our lives fighting with our tools. I think it's going to be huge. Anyway, sorry, back to the paper. This is a mind-blowing change, honestly, to the way that engineers work. And if you talk to Facebook engineers, and you talk to them about Scuba, or ex-Facebook engineers, they're just like, fuck, the thing I miss most about Facebook is Scuba. And I said that. Everyone I knew said that, and that's the way we built it. Anyway, paper overview. Time is mandatory, stamped by the client, rely on the client by default, because things like lag happen. Seems legit. It might smell like SQL on the front, but it's just convention. It's just because it's a very familiar name, under a familiar way of grammar. Under the hood, there is no schema. It creates a table as soon as it sees data for it. There are no schemas. It creates a column as soon as it sees like a key. And I love this. I love this, because one of the biggest problems with like debugging is trying to predict what data you're going to need. I don't know, that's the whole point. I don't know what problems I'm gonna have, so I don't know what I'm gonna need to debug it, right? So you have to incentivize people to capture everything. If it happens rarely, like give it the appropriate sample rate, but like capture everything. You cannot be relying on people's ability to predict the future. No schemas, no indexes. Wide and sparse tables, because since it's like a fake table, right? You might just want to write a whole bunch of different kinds of events there, maybe from different parts of the system. You know, this becomes like almost more of an art than a science. They're kind of curious decisions. Again, this evolved. This was not designed. Whoever would have thought of this shit? I wouldn't have. Most of these decisions were made at 3 a.m. But they've accidentally come to the best solution that I have seen for dealing with the problems of the future. And key to that decision is deleting a lot of data. For starters, you delete old data as fast as the new data comes in. It's great. When the nodes are, I'll show you how it fans out and like gathers data. But like if a node isn't responding, you just throw it away. Just throw it away and return and like, you know, maybe pop up a little, oh, we only managed to get like 85% of your results, but it's cool, right? You know, just like this shit is disposable. It's so good. For each batch of incoming rows, I love this. Scuba chooses 2 leaves at random, sends the batch to the leaf that has more free memory. It just periodically pulls it. And that's cool. Picking the better of 2 leaves instead of 1 leaf at random reduces the load variance from order log n to order 1. The leaf receiving the batch just stores a gzip compressed copy of the batch file because we are never, ever, ever CPU bound, right? We're always memory bound in these things. This doesn't really make any sense to me either. This is a terrible diagram. But what they're trying to get at is just like, okay, so over there, we're getting, there's your scribe, right? And they said scribe was like Kafka? That's so weird. Scribe's more like fucking syslog. But whatever, it writes things. I guess they both write things. Carries data. Dumps it into Scuba, and it's very generous with what it supports, right? It's just a JSON blob. Just a JSON blob. JSON blob and a write key, which is, yeah. And then you have the humble user who comes in and just like, well, whatever. Yeah, that's a terrible graph. Those are the data types that Scuba supports. They kept it simple, right? They kept it simple and dumb, and like if nothing else, you can just dump it into a blob, into a string, into a substring match, right? And they even have regular expressions. This is a terrible idea. But even the dumbest like intern can find something. It's great. So the architecture, I use the term loosely. God, it is amazing. This janky piece of shit is so great. It's amazing. So there are aggregators and there are servers, basically. Every physical server has like leaf servers, which actually store the data, and it has aggregators. And so basically, your request comes in, hits a root aggregator, which fans out to itself plus 4 more intermediate aggregators, and each one of them is like, oop, does like a count to see if it's scanning too many records, and then fans out to do like it plus 4 more. Until they can do, because they have to do a full table scan in every one of these. fan, all those full table scans in parallel, push them back up to your root, which returns it to the user. Is that not glorious? I love that. And there is that diagram. That symbolizes many, by the way. Oh, God. We aggressively throw away data. If it takes too long to return the results, this is like the anti-cap theorem. When in doubt, just toss it. Maybe don't use this for your billing data. I love this quote. Literally in the paper. We found that in practice, our response time improves if we throw our data away. so good. Changed my life, like I said. Oh, and then we get to the part where they literally, here's the paper, where they're just like, we are just going to restate with numbers the thing that we just restated with words so that we can put this in a white paper. And the thing that we guessed, this one guy guessed that 5 would be the right number, so we tried a bunch of other numbers, and yep, 5 was the right number. Like, that's it. That's all the computer science that you get. And the ways in which we violate good computer science are so many. You'll note that nowhere in this paper does it mention anything about replication. That's because one of the lines of C++ shells out to rsync. Hashtag, there I fixed it. But you know what? Like I said, talk to anyone who works at Facebook. They live and die by this thing, which is why there are very few people who care. And in fact, every boot camp class that comes in, they apologize for the aggressively hostile user interface that Scuba has. And then they ask, well, do you want to come fix it? No? Then shut the hell up. You should care because all of you, even computer scientists in the future, have to debug systems. And in the systems of the future are getting harder and harder to use our tiny little human brains to predict. And we have to switch from predicting and jumping around from metrics to logs and unstructured logs. We have to stop that. It's not good. We have to stop using tools that can't handle cardinality. Everything's a trade-off. I'm not saying the system is perfect. But I think that this set of trade-offs, pretty much line for line, is what we want out of our tools in the future. And over there on the left is Scuba. Beautiful. There's Honeycomb. Yeah, we don't actually have the luxury of forcing everyone to use Honeycomb, so we have to make it prettier. And there, whoops, I said welcome to the future. And that's the end. Thank you.
Thank you very much.